Okay, this is it. This is a titration problem. And titration problems are the culmination of all of your stoichiometry learning. If you can solve a titration problem, then you're on the right track. You've got stoichiometry down. Now, I'm going to give you a word of warning before I get into this problem. You will find videos on the internet that have you use the dilution formula, M1V1 equals M2V2, on titration problems to do a solution. What will that do? That shortcut will get you the right numerical answer in problems where the stoichiometry is 1-to-1. It will never give you the correct units. And so what those folks in those videos don't tell you is that they're just ignoring that. So in this particular example, the stoichiometry is 1-to-1. And so if you applied that method, you would get the right numerical answer, but the wrong units. However, in all of my exams and most other instructors, you're not going to see a titration that has simple 1-to-1 stoichiometry in every single problem. And so what that means is if you don't actually learn how to do it from a stoichiometric perspective, and you do M1V1 equals M2V2, you might get one wrong right without showing your work. So maybe some points off there, but then you won't get the other ones right at all. All right, so let's get into it. So what do we have? We have this problem asking us to calculate the molarity of an acetic acid solution. It says that it took 34.57 milliliters of the unknown acetic acid solution to reach the endpoint of the titration with 25.19 milliliters of a 0.1025 molar sodium hydroxide solution. And it gives you the balanced chemical equation. So if you want to calculate the molarity of the acetic acid solution, you need to know the number of moles of acetic acid divided by the liters of the solution. Okay, the problem has given you in blue there the milliliters of the solution, so you can convert that to liters. Again, I'm not going to show you the liter conversion because this should be something that you can do already. So it's 0.03457 liters. So all we really need to figure out is how many moles of acetic acid were in that solution. The stoichiometry of the chemical equation and the reaction will do that for us. So what's the plan then? We'll take some of the information that's left. I'm going to ignore the 34.57 milliliters of solution because we already know where we're going to use that. We don't need to use it in this stoichiometric planning, but we do have two other pieces of information we need to deal with. The milliliters of sodium hydroxide solution, and we need to deal with the molarity of the sodium hydroxide solution. We need to ultimately, as we just figured out, it wants us to calculate the molarity. And in order to do that, we need the moles of acetic acid. Okay, so what's the plan? Well, remember, we're going to use the milliliters of sodium hydroxide to start our plan because the molarity is a per expression and we never start our plan with a per expression. So we use milliliters of sodium hydroxide to start, and we can convert that to liters of sodium hydroxide solution. Then we can use the molarity of the solution to calculate the number of moles of sodium hydroxide, then the stoichiometry to calculate the moles of acetic acid. So let's put it together. It was 25.19 milliliters of the sodium hydroxide solution. Let's convert that to liters. And now here is where we use that molarity. The molarity will go here. 1 liter of solution was 0.1025 moles of sodium hydroxide. Now the stoichiometry from the chemical equation. This is the step that makes that shortcut work. In this case, the stoichiometry between the acid and the base is 1-to-1. Anytime it's not 1-to-1, that dilution isn't going to work. Okay, what do we get? We get 0.02582 moles of acetic acid. All right, so we're almost done. What we got to do is we got to take this formula for molarity and we got to stick in 0.02582 moles. When we put that into our calculator, we get 0.07469 molar acetic acid. And that's the final answer for this problem. Okay.